What's up? I'm AJ, and welcome back to Gen Z.
I'm here in Fort Lauderdale checking out the beach scene, and that's because I have some extra time on my hands. Many of you may remember from my last video that I removed the gauge cluster from the Fiero as I was dismantling and stripping the interior. Well, I enlisted the help of Pennick's good friend and longtime member, Mr. Jack Gunsett. Mr. Gunsett has lots of experience in restoring and fixing Fiero gauges, so I shipped my gauge cluster to him. He was kind enough to record the entire process of testing and evaluating my gauge cluster.
Thank you, Mr. Gunsett.
A little while ago, I was contacted by AJ and her dad, Todd, to look over her gauges, calibrate, and do any repairs that were required. They also asked if I could put together a small video clip on what I do, what I look for, and I told them I would be happy to do that. So here's the clip. I'll see you at the end of it again. When I receive a complete gauge cluster, one of the first things I look at is the back plastic with the traces on it. And if you have problems, that's probably a good place to start looking, especially if a light isn't working and you know the bulb is good. And I can already see over here on this piece right here, it has come loose. It's still attached, and that's for the high beams, a lamp over here. So we'll have to see if we can fix that. The traces are becoming very hard to come by. Doing my testing and calibration, I use some jumper cables if required, VOM meter. These are referred to as decade boxes. They're set up to calibrate the oil pressure, fuel level, temperature gauge, and it's just a series of resistors that I've got calibrated to run through. I don't just calibrate to one temperature or one pressure. Some tools to remove, assemble. One of the big ones is a frequency generator for the speedometer and the tachometer, and run those through the different speed tests or RPM tests, 12 volt power supply, and a soldering iron. Here we have 85 gauge set, and with these needles, they are very, very fragile. If there's any way possible, do not try and take them off. They're very brittle. I do go in a little bit of mild soap and water, Q-tip, and clean the needles up. Just want to show you the backlit style gauges, and these needles, they have a much broader area that you can lift that off, and I'll show you the tool that I lift these on. These needles have been on here for 35 years plus, and it's just sometimes very hard to remove them, especially the early gauge sets. These needles here I've happened to restore by removing them and cleaning them up and using a fluorescent orange paint on the back of them. Once the gauges are removed from the gauge pod, I run them through a quick calibration just to check them to see how far off do they need repaired, and I write those down on a sheet and supply it back to the customer so we know what we have to do to get the repair or calibration done. Using the frequency generator, I've input a signal for 20 miles an hour, and as we can see, it's 19. We'll take it up to 40. Input the signal here, and we're still about 1 mile an hour low. 39. Check it at 60. Still 1 mile an hour low. And we'll take it and check 80 miles an hour. and I'm going to say it's probably, it looks like about 2 miles an hour low at 80. So where do we go from here? To try and remove that needle and move it up 1 mile an hour, it's not risk breaking the needle. We're going to leave that, but at least the customer will know that it is 1 mile an hour slow. Now remember that the miles an hour and also the tachometer gets a pulse. So it's what the transmission is putting out. Your tires could have an effect on this. So all I can do is check to make sure that the speedometer will work correctly with the correct input. Here with the tachometer, of course, we have the 85s have got the oil pressure gauge in the bottom. The 84s have got a voltmeter. So with this here, I need to have my decade box hooked up, and it's actually hooked up for 80 psi. The positive is not hooked up, but once we do hook that up, with the frequency generator set for 900 RPM, obviously we have a problem. With the tachometers, the board's all the same. Either they're broke completely or the resistor is out. Some people talk about the capacitor. In doing this for 15 years, I have not found one board to have a bad capacitor. But by changing the resistor out on the back, I believe we can repair this gauge. To do this repair, we're going to go in and this trace right here, we're going to cut that, and then we're going to come down and put a variable resistor in across here. Now this procedure is written up on the Fiero forum and a couple other places. The nice part about having a frequency generator is the calibration becomes very easy once you install that variable resistor. Okay, I've done the repair, installing the variable resistor. So now we'll reconnect the frequency generator and see if this is repaired the tachometer. I've already gone ahead and hooked the power up and actually calibrated the variable resistor. With the frequency generator providing a 900 RPM signal, and we're right at 900. I've not found any of these tachometers to really be linear, so you're going to have a little bit off on one end or the other. I've normally found. I tried to set these up to be most accurate between 2 and 3,000 RPM. So we'll go up to 1,800 RPM, and that's actually a 60 Hertz signal. But if I was doing a V6 tachometer, this would actually only be reading 1,200 RPM. That's 18, looks pretty good. We'll go up to 27, and it looks like 26. And we'll take a look at, and that should be 3,600 RPM, and we're only 3,450. So I'm going to move it up just a touch to get the 2 to 3,000, which will actually put the lower end off maybe by 100 RPM. But for the fuel and temperature gauge, these are controlled by the amount of ohms that is sensed at the sensors. These can be, span can be opened up or narrowed by the resistors here on the back of it. These resistors range anywhere from 75 ohms to up to about 90 ohms. So if they aren't off very far, you can change that resistance slightly. That's going to either open or narrow the span, and generally when you have to do that, you're going to have to reset the needle on them. Mentioned ohms. When I fill my car up, it always reads it's pegged out. I can drive 45, 50 miles before it actually comes down and it's on the full mark. This is because you have a couple extra ohms resistance in that line that's running from the sensor up to the gauge. So take that into consideration. So I can only calibrate them from 0 to 90 and set that. I'm not sure what's going to happen in your car. The temperature gauge, an easy way to check that if you have in doubts is get a hold of a 100 ohm resistor and remove the connector back on your temp sensor and insert that into the connector and ground it out on the block, and you should read right around 200, 220, somewhere right around in that area. If you want to check the low end, that's about 55 ohms, and the upper end is about 1.3K. So, but the easiest way to do it is just use a 100 ohm resistor, and you should come out right around 220, plus or minus a bit. Hopefully the video helped explain some of the calibration, what goes into it, if we find a problem or repair. In there I also mentioned about removing the needles from the backlit gauges, and I use nothing more than a trim tool. I use a piece of tissue paper on the gauge face to give you a little bit of leverage and to lift that off easily, gently. On the forum, you can find me at J_Gunsett. And if I can be any help, I'll also put my email address down here. So if you have any questions, please let me know. Hopefully you enjoyed the video. Thank you very much for watching.
Thank you again, Mr. Gunsett, for fixing up my gauges. Now the tachometer is working and I'm so excited to install it into my car. Now I have much more time to go shopping.
So, what do you want to do today?
Here comes excitement. Pontiac. Here come the hot cars. Built with a feel for the road. Pontiac.
So, what do you want to do tonight?